Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 23, 2026, just yesterday. It introduces a compact unified model capable of generating images on a standard iPhone in just 3 seconds, while running up to 11 times faster than comparable systems like Show-O and JanisFlow. The paper is titled Mobile-O, Unified Multimodal Understanding and Generation on Mobile Device. And as we'll see later, the results for both visual understanding and generation are really impressive given the low compute budget. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 demonstrates these capabilities in action, specifically showcasing performance on an iPhone. The left side highlights 3 tasks: generating images in just 3 seconds, identifying pasta ingredients in milliseconds, and even converting sketches into photorealistic images. On the right, the charts compare this performance against larger models like Show-O and Janis. The green stars indicate that Mobile-O achieves significantly higher accuracy and speed while consuming far less memory. Figure 2 reveals the architecture behind this efficiency. On the left, the diagram shows the dual pathways, one for understanding visual inputs and another for generating images, both anchoring to a shared autoregressive language model to save memory. The key innovation is the green component in the middle, called the Mobile Conditioning Projector. As the right panel details, this projector avoids heavy computations by simply fusing features from different language model layers with lightweight convolutions, creating a fast bridge between text and image generation. Well, Figure 3 outlines the unified post-training pipeline. It introduces a unique quadruplet data format, using a generation prompt, an image, a question, and an answer all at once. On the left, the system processes the question and image to predict the answer, calculating an image-to-text loss. Simultaneously, on the right, it uses the prompt to drive the diffusion transformer for a text-to-image loss. By optimizing these objectives together, the model aligns its understanding and generation capabilities much more efficiently. So, Table 1 details how this training pays off, comparing Mobile-O against state-of-the-art models on understanding benchmarks. The most relevant comparison sits in the bottom section, which lists unified models with fewer than 2 billion parameters. Here, Mobile-O leads the pack with an average score of 62.1, clearly surpassing JanisFlow at 57 and Show-O at roughly 47. It even outperforms its own understanding-only counterpart, FastVLM, showing that adding generative skills actually boosted its perception. Alright, well, Table 1 focused on understanding. Table 2 evaluates text-to-image generation, using the General Eval benchmark. The rows here are grouped by model type, and the bottom section specifically highlights unified models with fewer than 2 billion parameters. In this category, Mobile-O secures the top spot with an overall score of 0.74. This result outperforms Show-O and JanisFlow by substantial margins, demonstrating that the compact architecture does not compromise generative quality. Moving to Table 6, we shift focus from quality to real-world speed on edge devices like the MacBook M2 Pro and Jetson Orin Nano. The top section reveals that on a MacBook, Mobile-O generates an image in just 4 seconds, which is drastically faster than JanisFlow at 24 seconds or Show-O at 47. The middle section shows a similar advantage on the Jetson platform. Finally, the bottom row highlights the iPhone 17 Pro, where the model delivers a complete image generation in only 3 seconds. Wrapping up, Mobile-O proves that high-quality unified models can thrive on edge devices without relying on massive cloud compute. Its combination of the lightweight mobile conditioning projector and efficient post-training sets a new standard for speed and accuracy on mobile hardware. This breakthrough opens the door for fully private, real-time AI applications that fit right in your pocket. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.